Yeah, sorry about the recording. I forgot to press the record button. Now I just press it. So the previous part doesn't matter. You still have the first part. Okay, just for in case if you want to watch back, if you want to revise anything like that. Okay. So okay, now let's continue. No choice. Just continue. Okay. Now we see example. Yeah. 5:30. Okay, 1 hour already passed. Now example. If I say, wait. Okay, example 1 here. Look at here. A ball of mass 2 kg is dropped from a height of 1.8 meter. What is its velocity just before it hits the ground? So this one you have to use the energy concept. Okay, so if I draw it, a ball of mass is dropped from a height of 1.8 meters. Okay, so it wants you to calculate what is the velocity here, v, just before it touches the ground. Okay, so first you have at the first point up here, I label it as point A and the bottom as point B. At point A, what is the potential energy? Okay, so all the energy is in potential energy form. As the ball starts to drop, the kinetic energy starts to increase, and just before it reaches the ground, all the potential has been converted to the kinetic energy. Right? We discussed this right just now. So meaning that the potential energy loss will be equal to the kinetic energy gain. So how do you calculate the potential energy? mgh equals to kinetic energy is half mv squared. Okay, so since the mass is given here, okay, the mass given here, I can just put it in, just put all the values in. Okay, so you have 2 kg 10 1.8 equals to half 2 kg v squared. Okay, so you calculate 10 times 1.8 times 2. You have 36 here equals to v squared. So v equals to square root of 36, 6 meter per second. So the final velocity is 6 meter per second. So understand this one, right? Potential one form of energy loss will equals to the another form gain. So if I tweak the question, if I ask you, what is the work done? What is the work? Not what is the work done. Let's say if I don't write the mass here, the mass is not given 2 kg. If the mass is not given, then doesn't matter. Doesn't matter because why? Because you see your equation here, you have m and m, right? So technically you don't have to calculate the mass. We can just cross it, cross it. So it equals to GH equals to half of V squared. Okay, technically you don't need the mass. Okay, another example I want to show you is that question 40. 1 minute, 1 minute to understand the question. Okay. In figure 2.39, an object of 2 kg mass is pulled by a force from A to B. So pull up. If the object is stationary at B, the work done to overcome friction is work done to overcome friction. Now understand the concept. Understand the concept. You see, from point A to point B. At point B, the object gains potential energy, right? Because it is at a certain height. Now, the amount of potential energy gain comes from the work done. Remember, work done is equals to the change in energy, right? Comes from the work done. So first you calculate the work done. What is the work done? W equals to F times distance. So remember, force and distance has to be in the same direction. So if the force is diagonal here, so you take the diagonal distance. Okay, so 8n times 5, both acting diagonally. So 40 joules. Okay, so when you move this object up to point B, meaning that you have done this 40 joules of work on the object. So by right, the object should have gained 40 joules, right? By right, it should have gained 40 joules. Now let's calculate what is the potential energy of the object at point B. Again, potential energy, I write here, equals to mgh equals to 2, 10, and 1.5. Okay, what is the answer? 20, 30. So you get 30 here, 30 joules. Now, here's the part. Here's the important part. At the top, at B, the total potential energy gained by the box is just 30 joules. But the work done is 40 joules. Why? Where is another 10 joules? Right? Another 10 joules is used to overcome the friction. Okay? Another 10 joules, so you get 40 minus 30. You get 10 joules. This 10 joules is used to overcome the friction as it goes up. Okay, so you can say that this 10 joules is the energy loss. But understand that when I say energy loss, it doesn't mean it suddenly disappear. Okay, it has been changed to this heat energy to overcome the friction. So your answer is A, 10 joules, work done to overcome friction. Okay. Okay, take a screenshot of this one and keep the example. Then we look at the next one. Okay, next question is 72. What time is it? 30. 72. Okay, question 72. Okay, this is quite similar to the previous one that I've shown you. Okay, so basically you want to calculate what you want to calculate. Determine his speed just before he lands on the ground. Okay, so in this diagram, you see this diagram, you have this guy skis down a hill from point A all the way to point to the ground. Okay, pass through point B and to the ground. Okay, so you want to calculate the speed just before he lands on the ground. So first, using the concept of conservation of energy, what is the total energy at A? Okay, so I write down here total potential energy at A equals to what? mgh. So you calculate mgh. So m is not given here, right? M is not given. Okay, never mind. You use this one. Total potential energy loss will be equals to the total kinetic energy gain. Okay, so mgh equals to half mv squared. Okay, I repeat, total potential energy loss at A will be equal to the total kinetic energy gain at the point just before he reached the ground. Not at B, not at B, it's at the bottom. Okay. So mgh, you cancel out the m, so gh, so 10 times what height do you take? 6m or 10m? You take the total height, 10m, okay, not 6m. 6m is just from B, equals to half of V squared. So you calculate the V. Okay, so V equals to 14.14. 14.14. Okay, now let's move on. Let's move on to the next part. Okay, so another 20 minutes, then we'll do the exercise. Now, next one, just a little bit more, is the power. They are all related. Power. Now, if you think of power, it means that how strong something is. Okay, if you have great power, you're strong, right? So strong. What is another meaning of strong? If I say you're strong, meaning that you can do work very fast. Okay, pick up the boxes. You can pick it up very easily. You can pick it up very fast. Pick up the boxes and go up four flight of stairs. If you can easily do it, if you can do it very fast, then you are strong. You have power, right? So if you really think about it, power is the rate of work done. Okay, in other words, you can say that it is how fast the work is done. Let's say person A here carries a box. Okay, not okay, just empty hand lah, empty hand. He runs up the stairs. Okay, his weight, his mass is 50 kg. He runs up the stairs of 10 meters in 20 seconds. And you have a person B here, same weight, 50 kg, same mass, same height, 10 meters, but he runs up the stairs at 10 seconds. Which one possesses a higher power? Of course, it's person B, because he can finish the work in shortest amount of time. Okay, so power, if you want to calculate power, power will be equal to work done divided by time. Okay, how much the work is done, divide by time. Just add one time inside, then you get power. So work done is Fs, right? So F times S divided by T. So if you want to calculate the power of person B, then you calculate what is the force? The force is equals to its own weight, okay, because he's lifting his own weight. So 500 Newton times 10 meters, that is the work done, divided by the time, 10. So equals to same 500. What is the unit for power? Okay, unit for power you can write joules per second or watt, W-A-T-T, capital W. This is the symbol. Okay, why joules per second? Because if you look at the formula, P is equals to W除 T 嘛，对不对 ？W 除 T， W 的 unit 是什么 ？W 的 unit 是 joules，T 的 unit 是 S，so you have JS minus 1， or you can write as watt, but usually we write watt lah. Okay, capital W. That's it for power. It's straightforward. Okay, so calculate the power, you need the work done, and you need this one. Sometimes power you have to use another formula. You got two formulas for power. Okay, another formula is this one. P equals to F times V. Okay, how do you get this? Like this. Initially you have P equals to work done divided by T, right? So work done is F times S divided by T. So this one, you see this S and T here, right? Is displacement divided by time. What is that? That is the speed. Right? That is the speed. So equals to F times V. Force is simply the same as the weight. So you have second formula is P equals to F times V. This one, these two formula. Okay, now 2 more examples I show you, then we are finished. Look at here. Give it 10 minutes. Yeah. Okay, question 73 is just a very quick question here. Okay, okay, look at the question. A typical steady power of a man is 100 watt. So the power of this man is 100 watt. Estimate the speed of this man if he has a mass of 70 kg, if he climbs upstairs steadily. Okay. He weighs 7 kg. If he climbs up the stairs steadily, what is his speed? Given his power is 100 watt. So P, do you use this one? Work done divided by T? No, right? Because there's no time given here. There's no time given here, and also the question asks you to find speed. So P, another formula would be P equals to F times V. Okay? P equals to F times V. So what is the force? The force, he walks up the stairs, right? So it is his own weight. He lifts his own weight. So 700 force. 700 force acting up times the velocity equals to his own power, 100. So straightforward, V equals to 100 divided by 700. You get 0.14 meter per second. Okay, next one. Okay, next one is question regarding the efficiency. Okay, now just a quick note here about efficiency. Efficiency means how efficient a device uses the energy. For example, if you supply 100, let's say if you supply 1000 joules of energy to a device, It can be any device like your electric appliances. 1,000 joules of energy. Okay, so it only can use 800, let's say. It only uses up 800 joules of energy, and the rest, which is 200 joules of energy, is wasted. Do you say that the device is efficient? What is the efficiency of the device? It's almost 80%, right? It's almost 80% because given 1,000 joules, it uses up almost 80% of the energy supply. So something like this one, efficiency, right? So you have to know that all devices on this planet, no devices on this planet is 100% efficient. Okay, I mean this can be argued. Okay, because sometimes the scientist is able to achieve very close efficiency, very high efficiency, but still, until now, we still haven't reached the 100% efficiency. Okay, so efficiency, just a quick one. Symbol looks like an N, and you have EFF here. Okay, I don't know, I'm not sure whether this symbol is in your textbook. Okay, but in university we learn this symbol as the efficiency. Okay, but doesn't matter. Okay, doesn't matter. You can just write efficiency. You can just write EFF. Okay, efficiency equals to power output divided by the power input times 100. Then you get the percentage. This one, you get the percentage. Okay, now notice the difference here. Power output is the power that the device carries out, or you can say that the power that the device performs. Power input is the one that it is meant to perform. Okay, you see the difference here. For example, you have a device, right? If the device, there's a sticker there, it says that the instruction, it says that this device is able to perform 500 watt. This is what it is meant to perform, right? What is meant to perform. You should expect it can perform 500 watt because the instruction says that, right? But when you plug in the device, let's say you plug in a device and you start to use the device. Okay, you start to use the device, then the power that the device perform is only 400 watt, let's say. It is lower, right? It is lower than the power that it is meant to perform. So power output is this one. Okay, the actual power that it performs. And power input is this one. Okay, this is the power that, you can say the power that's supplied, or you can say that the power that it is designed to perform at. Clear? Right. So back to the question. This one. So a motor with a power of, okay, 我有3分钟40秒，看我够不够快这边。Okay now. A motor with a power of 12,500 watt raises a lift. Calculate the efficiency of the motor if it carries 8 persons with total mass of 560 to a height of 20 meters in 10 seconds. So you see this one power, this one, the first one, 12500 is the power input or output. It says that a motor with a power of 12500. So this is like the power rating. Okay, so this is the power input, 12500 watt. Okay, because this statement, it just says that, oh, this motor has this power. Okay, so it is something like the design, the power that is meant to perform, the power rating of the device. And then after that, it says that calculate the efficiency, and if the motor carries 8 persons with total mass of 560, now this is the work it performs, right? This is the work it carries out. So you have to calculate power output, this one. Power output equals to what? Work done divided by time. So you have force times distance divided by time. What is the force? The lift, the elevator, the lift up 8 persons, right? Total mass of 560. So this is the force. It is lifting this force times height of 20 meters divided by in 10 seconds. Okay, so usually power output is the one that you can calculate. Power input is the one that you don't have to calculate, just given to you. Okay, so 560 times 20 and then divided by 10. So you have 1120 watt. Okay, 1120 watt. So now you calculate the efficiency. So power output 1120 divided by 12500 times 100. And you get the efficiency. Okay, this one I don't have to say lah. You just calculate lah. Use the calculator. I think is answer. I think is A. Very close answer. Okay, now we have finished the lesson today. You have learned about work done, power, efficiency, and energy. Now I have 我有很多 exercise 在这边. I think this one is because this one is taken from all the physics workbook. It has 100 more questions, 100 plus. So when you finish this worksheet, technically you are finishing multiple workbooks. Okay, so it's better that you have time. Of course, you want to try it all. If you have time, okay, you try it all, then you will start to get used with the questions, and then it feels natural to you after that. Okay, so I have 1 minute here. Remember, I will send you the link again, so you join again, and then you can take the rest of the time, 30 minutes, to do the exercise. I will send the exercise in the WhatsApp group. Okay, so any question, please let me know.